Okay, and I'm going to share the screen. Okay, and so we're going to move to, yeah. All right, so you guys are section 1, if I remember correctly, right? So that means that I wrote down that we haven't finished. We finished quite a bit of the basics. All we had left was to do some additional image processing. All right, I think we didn't do that. The example of the cats, right? 3 files, 3 cat files. Did we do that? The 3 different images of cats.
Different images. You had 4 on there originally.
And we processed them. We did that. Yeah. So that's I don't have. I have Celsius to Fahrenheit. We finished. Read in data to PyTorch, TensorFlow basics, but I don't think we did the cats. Yeah, we didn't. Okay. Yeah, I don't have a Jupyter here, so I guess I'll take a look. But yeah, so we'll do that today. And then I will also show you how to read in a data set from, like Sci-Fi 10, etc. So that'll be just pretty short. And then after that, we're going to get into linear regression, right? So we're going to do linear regression today mainly, which will be, loading some data. We're going to load the wine data, and then we're going to build a model in PyTorch. Any questions before I begin? Okay, so I did post some of your grades already. And then I'll be working on the other part, the other homework assignment. And then once we finish this regression, you'll have a homework assignment, okay? Which will be finding a regression data set and kind of replicating these results. Okay, I know for sure we haven't done the regression code in this section, right? All right, so let's go ahead and get started. So as you can see, I already have this. So I'm going to look at Conda environment list. And I'm going to activate the environment. Conda activate Pi37 ITS 521. Okay, so we're going to load this up, and then we can start the Jupyter notebook. Notebook. Okay. All right, so it should be this file, read in data to PyTorch, I assume. This is where we left off, I believe, with this section. So we did reading in the dog, Bobby. And then we went over, okay, so we did do some of the cat loading the files, normalizing the data. So we went over that. Loading CSV, we did that. And today we'll be using the wine quality CSV again for building a regression model. Okay, and so basically we got as far as that. And so, yeah, we haven't done the part. So if you notice, we read in some images, but we really didn't display them or anything like that, right? So that's what we're going to do today, just to kind of play a little bit with that. I don't plan to spend too much time on that, but it's interesting to look at images, okay? Now, there's a lot of frameworks on processing images, okay? And I'll just do, just kind of for your own information, a very brief example of how to read images from a folder. And then we're also going to read in some images from like PyTorch libraries. Okay, so that's another useful thing that we can do. All right, so let me go ahead, I guess, and rerun this. And I'm just going to utilize this script. So clear the output. And then we can start a new section. So I'm just going to run. We were using image IO. Move this down. Okay. All right.
Can I ask a quick question?
Yeah, go ahead.
With the image IO that in read, can you actually put in a HTTP link instead of reading from local? And also,
In a lot of the libraries, you can. I don't know the specific syntax for that. Some of them, it is as easy as just putting in the URL.
Right.
I don't know if IMRead will do it, but you'd have to look at the example. But in general, you can with some. You just, and they're not all consistent, you know. All right, let's keep going. So as I said, I'm just kind of loading all of this, so I have all the libraries that I need, but we're really starting something new. And I just want to utilize this Jupyter notebook. All right. So anyway, you know, images is something that you use quite a bit in machine learning, and we're certainly going to explore this in the future after the regression models. And so, as just to kind of conclude with the basics intro, we're going to play with some images this time around and kind of display them, etc. Okay. So for this example, we are going to use, so I'm going to introduce another library that is actually very popular for machine learning, which is a native library of that Python uses a lot called PIL. And so we're going to play with that one a little bit. All right, so I'm going to introduce that library. Let's just call this like playing with images. Okay. So mark that out. All right, and in here, the library in question, we may need other libraries, but for now, let's just do from PIL, uppercase, we're going to say import image, comma, and that should be uppercase, both. Image, comma, image, draw, comma, and image filter. We may not use all of these, but this is just an example of bringing in libraries, okay? So let's go ahead and run that. So that gives us the libraries. And now we should be able to read in an image, all right? And this time around, we want to display it, right? We want to do more than, you know, obviously, we would need to convert it to tensors, et cetera, as we did in last week's class. But here, as I said, my goal is more to play with the images and view them. So I'm going to do, let's load an image, original. Let's call it original IMG. And we are going to use image from PIL, image.open. And then these should already be in our folders, right? So we had specified this data /data. And then we have a folder in there called image cats. And then, you know, we can select any of the cats available in there. Okay. So we're going to do cat1 .png, for instance, all right? So we're going to read it in, and then we want to view it. So that's the nice thing about PIL, is that it lets us process. So let's go ahead and run that. Oh. All right, let's look at this. So data. Oh, okay, so we don't have it's just one level. Okay, let's go ahead and run it again. And there we go. We have a cat. Okay. So now we're going to read another cat, and we're going to start, you know, playing with these images, right? So my goal is I'm going to read another image, and then what I want to do is I want to add one image to the other image. So imagine if I had a blue sky, and then I have a bird, and now I want to have a blue sky with a bird on it, something like that. But I don't have that. I just have cats. All right, so cat in front of another cat. All right, so let's do then, and let's read in. Obviously, we need a second image for this. So let's call it image to add, to be very clear. Image to add. We're going to read in image dot open. And then once again, it's going to be data image dash cats or /, and then this is going to be cat2 .png. Okay, So let's go ahead and read that one and print it out as well. Okay, so we can run that. And there we have another cat. Okay, so now the question is, we want to put another, another one image in front of the other, right? So that's like a pasting operation. Okay, so let's do that. Let's call that paste image. One scenario where you would use this is like if you were doctoring images or you were creating adversarial images and you want to insert something in another image. Okay, so let's do the markdown. All right, hit run. Okay, and now basically all we have to do is we invoke the original image because we're leveraging PIL's functionality. So original underscore img dot paste, and we're going to paste into it img to add basic. Okay, we can also save this image if we wanted to. So we could do, once we've modified it, we would do original img dot save and save. And in this case, we want to save it in the same location. So we can say data, and then let's call it adversarial cat1 dot jpg, for instance. And we can say something as far as the quality that we want it like to be 99% or something, right? So, all right, so let's go ahead now, and we can print out the original image. Now, if we look at original image, it looks like what? It looks like this cat, right? And then the second image is this one. And we are pasting into original image the second image, right? Image to add. Does that make sense? All right, so let's go ahead and do that. And you guys can tell me. So do you think it worked or no? No, it didn't work?
Did it cover it?
Yes, why? It just covered it, right? So it's on top of it. They're both the same size. We had established they're like 250 by 250 or something. So what you probably want to do first is you want to resize image to add so that you can see the effect, right? So let's do that. So I'm going to add a couple of cells in here, and I'm going to say resize. I'm going to do resize here, and then the cell type markdown. There we go. Just labeling a little bit. And now it's pretty easy again with image PIL. It's super easy to make modifications. So you can just do image to add, right? Which is the one we're going to put on top of the first image. And we can say we want image to add dot resize. And we can specify the size. Now it's very easy with these because they're square. So we don't have to worry about aspect ratios and things like that, which can be an issue. And this is really important. All this image processing has to be done when you're dealing with images for various reasons. So it's a set of techniques, and Torch Vision is a companion to Torch that helps you to process images. However, we're not focusing on that right now. We're just I'm just showing you some of the basics. So now I'm going to go ahead and resize the image. Okay. And then I'm going to hit this and then that. And then, did it work?
Yeah, but the original.
The original was the image to add, right? So we kind of need to go all the way back to the beginning, right? So let's go to the libraries. Let's reload original image. So now it's this cat. And then we reload image to add. Now we're going to resize it. And then now it should work in theory. So we go over here and there we go. And we've done that. However, one last thing you may want is you don't really want the image just in the top left-hand corner. You want to specify a position where you want to paste it in. So in that's also pretty straightforward. let's go ahead and, oops, sorry. Let's go ahead and do original image. Original IMG dot paste. And then we're going to add image to add, comma, and then we want to specify where we want it. So you can play with these parameters, but it would be that these are the positions on the image. So 100 and comma 50, for instance. So now that we've done that, we can print out original IMG like so, and hopefully that will, oh, no. IMG, yeah, it's IMG. Right. IMG to add, and there you go. So you've added the picture. It's pretty easy. You see that? So this is kind of the complement of what we were doing before, where we were manipulating the tensors. You also sometimes want to look at the images themselves. All right, let's see. One other thing we might want to do is we want to, obviously, when you load an image with PIL, you're going to need to convert it to a tensor, right? So that means you load the image with PIL and then convert it to NumPy and then convert it to something. All right, so let's do that. We're going to play with the third image. Let's call this will be image PIL to NumPy, okay? So that way we can view the image and then process it and then convert it to. We've already done NumPy to tensors to torch, so we don't have to do that part, but at least we're going to convert it to NumPy. All right, so we can add a new here. We can say image PIL to NumPy. Cell, markdown, run, okay? And so now we're going to load another image. Let's call it my IMG. And we're going to load the third cat, image.open. Okay. So we can say data / image dash cats / and let's load cat3 dot png. Okay, so we're going to load the third cat, my IMG. Okay, and then this is the third cat. All right, so what we want to do now is we're just going to convert it into a NumPy array. And with image PIL, it's straightforward. So we can do, let's do IMG underscore NP. And we're going to use numpy.array, right, to read in my IMG. Okay, so we read in my IMG, which is this image, and we're going to convert it into a NumPy array. And then we can just print shape. So let's do IMG NP dot shape. All right, so let's go ahead and run that. And there we go. So we've got 256. It was 256 by 256 by 3 because these are color. Got it? And from here, you guys know how to take it to the other. So when you're doing a lot of machine learning, sometimes you have to take an image, play with it somehow, and then after that, convert it into a tensor and finish it up. Okay. Now, this is just more of like an exercise to see how sharp you are with your slicing. Let's say that I want so I want to get rid of the last channel. Let's say that's the problem on the exam. You know what I mean? So then I ask you, okay, give me the slicing syntax, right, to get rid of the last channel. So it's RG, so the blue channel, I guess, right? The last channel. So theoretically then, what would you need to do? Let's create a new IMG, right? But this is an NP, right? NumPy. And we're gonna do what? Slice it, right? Should know this. Need to be sharp with this. Needs to be your life. Tattoo slicing on your arm. All right, so what is so obviously the NumPy is IMGNP, right? IMGNP. Okay. Do we want these dimensions to stay the same? We do.
Yeah.
I just think about the question, right? Get rid of the last channel. But 256 by 256 should stay, right? So how do you keep that? Colon, right? Okay. Colon. Yeah. Uh-huh. Now what about :2? Nice. Good job. All right. Very good. Yeah. :2, right? How do you corroborate that that worked? I mean, why did I do it? Just, because I wanted to. But you can print the shape, right? So we have the previous shape, and now we want to look at this new shape. So I call this my new IMG NP and then dot shape. Yes? So we're going to go ahead and run this one. And we remove one channel. You see that? Now let's go ahead and this NumPy, let's make it back into an image. Okay, so that's going to be with PIL. So let's call it PIL image, right? And we're gonna invoke, so it's straightforward, right? So this is something you might need to do. As I said, you might need to process things and then want to look at the image to see what it looks like and so on. Okay, it's a very common practice, and this is like trivial compared to all the things that are recommended sometimes. All right, so now you're gonna need to load it into an image, into an image pillow example. So basically image PIL has the image module has a function called from array. Okay. So the PIL is very common. So if I ever give you a homework assignment that involves images, you're going to see PIL being used quite a bit. All right. So obviously the file is my new IMGNP. Yep. P. All right. And then once we've loaded it, we may want to look at it to see if there was any effect. Right. And so we can run it. And you can see the image is basically missing a channel there. And it changed a little.
Is that it's missing a lot of channels. It's now grayscale.
It's grayscale, yeah. So don't ask me. I mean, you can dig into.
I mean, where's red?
It may not have loaded it correctly into the image. So it's definitely modified. So I mean, I don't know the effect of just red and green. All right. Yeah. Okay.
I mean, because the original image has a lot of yellow.
Wow.
And that's definitely redness there.
Yeah.
I mean,
It may be that it didn't load correctly. So it may
you-
have read it as a grayscale by default, or yeah.
It's not RGB then.
I don't know. I mean, I haven't really I didn't dig into it. I just wanted to look at the effect.
Oh, I see. Yeah.
But yeah, you can look. I mean, you can look at it. What the default, because from array maybe. Oh yeah, go ahead. Yeah.
But you need to shape that, because it's there from 1 or from 0. It's three, that 3 could be out there.
But see, it's showing 2 here, and this would be there's no 0 there because it implies that there's 2. Before there were 3. You see that? So you want me to slice more out? Is that what you're saying? Like 0 and 1? I mean, I can do that.
So right now it looks like RGB, R and red and G are gone. B is almost none, so that's why it's showing like a shadow. It's,
Yeah.
in fact, to me, sounds like it's RG, because red, G, B is blue, right? Red,
Yeah, RGB.
yeah, so it's
Red and
almost
green.
like the red is gone and it's.
Maybe, I mean, it could be that it's not RGB, maybe it's BGR.
Right,
We,
something like
you
that.
gotta dig into what the function is actually doing.
Do you want to just change one slice and slice? instead
Slice
of-
to 1?
Yeah,
Yeah, I don't think it'll change anything, but like that.
yeah.
I mean, yeah, this is the fun thing about this. You can play with it, right? So there's lots of things you can do. See, it didn't like it. It doesn't want something, because it only finds one dimension there.
Oh,
So
something is, somehow it's not RGB.
Yeah. don't worry about this
Yeah.
though. It's not, that's not the goal of this exercise, right?
Okay,
Yeah. So this exercise was just to do a slicing thing and then load it back into the NumPy array. There's tons of things that you can do with image processing. All right. And we should use the appropriate functions. But yeah, good questions. And I encourage you guys to play with it. If you're curious about it, what you should do is read into what from array is expecting. Okay. And then see what, and more appropriate things are like saying converting specifically from one data type to another, because this was a JPEG or a PNG, and that's going to influence, or a BMP. All those things are really important. Okay, so the format, etc. But this was just an example of slicing, getting rid of one channel, and then obviously the image looks like that. All right, I have one last example, which is this one should be a lot of fun, I think. I want you to think, let's say I could give you another problem, right? I want you may not remember this because, your generation probably never saw this, but old analog TVs, when the antenna, when there was no programming anymore, what would you see on the screen?
Are you talking about test camera or are you talking about snow?
Snow, right?
Yeah.
Yes. Static.
How far back do you want us to go?
Right. So you would, once once the no programming was available, get some kind of a patriotic stuff, and then like static, right? So I want you guys to generate, how would you generate an image that is pure static? How would you do? How would you go about it? It's an exercise, right? A fun exercise, because this one you can actually visualize. But it involves things that you know how to do with this. I just showed you. So what is that static, or that snow as you called it? It's random noise, right? There's no pattern that I can see. I mean, for those of you that took cryptography with me, and we've done this exercise before, a random thing looked like snow. And so I want you guys to generate an image that is that. How would you do it? Just tell me. You don't have to what would be the steps that you would follow?
So generate an array with random numbers in it,
Yeah. And then what?
and then use PIL to
Yeah.
make it.
And what do you use to build it?
Oh, the NumPy.
NumPy, right? That's it. Yeah. See how much power you have? So you can do this with 2 lines of code, right? So we're going to do that. Let's call this exercise noise image. This is something that you may have to do sometimes, right? If there's an autoencoder, called a denoising autoencoder. What does it do basically? There's an image with noise, removes the noise, right? How do you add noise? Now you know how to add noise to images. Does that make sense? And so that's kind of the idea. Okay. So all these things are relevant later. Okay. So let's go ahead and build a noise image and print it out. And then that will be we'll move on to the data sets just real quick. And then we can start the regression model. So noise image markdown. So we can do run over here. And now, yeah, let's create, and let's just generate the random noise through NumPy itself. And that way we're there already, right? So we're going to create an array, and I'm going to invoke NumPy, NP, and then I'm going to say random dot rand int. You guys see that int because it goes from 0 to 255, and then you can specify the scale. So 255, comma, and then you want to specify for this array the size of it, right? So it doesn't have to be 250 by 250 for this one. Let's just do let's try 400 by 400. See how big that is. And also you want to specify the data type. So we did examples like this before, but this time around you're generating an actual image. Okay, so that's going to be np uint 8, for instance. Okay, and that should be our array. And then let's convert that NumPy into an image with PIL, right? So we just learned how to do that. So I'm going to do image dot from array. Notice it's the same command, and we read in array. You guys see that? So now I'm going to go ahead and hit run. Okay, and now all that remains is to render the image, right? Because it's an image. So if you hit run, did it work? There you go. You have your static noisy image. It's an image, it's noise. And then from there, you could add this noise to actual images, right? And so noise it's something that is in everything, right? And like in the real world, every sensor, everything, every picture you take, there's noise. Either the technology fails or there's something, etc. Okay, any questions, guys? All right, so this is an example just playing with images. The last thing we're going to do related to this concludes our basics discussion and also our loading data into Torch, right? So the last thing I want to do is I'm going to discuss, we've talked quite a bit about reading data from the folders, from file system. Now we're going to read in data from the libraries that Torch has. So Torch provides some data sets as well that we can use quickly. Right, so if I say at some point homework, use Scifar 10, you'll know how to get it. Okay, so let's go ahead and do that, and this will conclude this section. So we're gonna think about loading Scifar 10. So what is Scifar 10? So first of all, there's MNIST. MNIST is a large data set of 60,000 images in black and white, okay, of handwritten digits. It's very famous. Jean LeCun, who is the head of AI at Facebook, Meta, created it back in the 90s. They were doing this for the post office, so that, zip codes, right? We all write zip codes in handwritten numbers, and so they wanted a sorting mechanism, and they got it to work in the 90s for the post office. So very famous project. Jean LeCun is very famous. Okay. So the problem with MNIST, we will use MNIST for some problem, right? But the problem with MNIST is what? Black and white. So why is that a problem? Because building a neural network in black and white is very simple. Whereas if we have RGB, the colors, the tensors become a little bit more challenging. You see what I'm saying? And so a lot of people saw that, problem, and they created Scifar 10. Scifar 10 is meant to be like MNIST, but it's in color, so it's got RGB. So it's very convenient. So I think the only difference is, like, instead of MNIST is 28 by 28, Scifar 10 is 32 by 32, and it's not handwritten digits anymore. It's like cars, birds, and stuff like that. So we'll play with that just a little bit briefly, and then we'll wrap up there, okay? So for this one, we will probably need Torch Vision, actually. I think we use Torch Vision for this one. All right, so Torch Vision, I believe it's installed already. So you guys can go ahead and try it out. Once we start doing more advanced things with images, I'll just start throwing in Torch Vision because it's got a lot of nice functions that we can use. But let's call this Cipher 10. Markdown, hit run, okay. And then hit plus sign here several times. Okay, so let's go ahead and see if it works. So let's do from Torch Vision import datasets. Okay, so let's see, let's run it. Oh, why is it not so? Well, let's do it then. I guess I installed it in the last class. All right, so let's add a new cell and let's try pip install. Can you guys try this? Pip install Torch Vision and see if it installs faster on your computers. Okay, that's a good sign. All right, good. And now let's hit Torch Vision. Oh, I hit it again, sorry. And then I'm gonna comment this. Okay, and do that. Okay, it's thinking. All right, good. So we have it now. So now your environment should have Torch Vision going forward. So now we can, and I ran this, so now I have data sets. So if you notice, this module data sets should have several libraries, right, that you can use. Okay, so let's go ahead. There should be a function. I don't have the function. If you guys find it, let me know. But there should be a function to list out all the data sets available in Torch Vision. So that's handy to know. But let's just use invoke Cipher 10 for this one. So the advantage of these functions is that if you don't have, what they do is they go online, grab the data set, put it in a local folder in your system, and then leave it there. So the next time around, they're not going to download it off the internet. They'll just look to see if you have it already. Does that make sense? So, you know, we need to specify then a path where we want to save this. So let's just say data path, and it's going to be equal to, in our data folder, we're going to create something called Cipher 10 data. Okay, something like that, some folder, and then we can just go ahead and download it. So I'm going to say Cipher 10, create a variable so I can reference it, then invoke datasets dot Cipher 10. Okay, and then I'm going to read in, you know, the data from the web into this folder data path in my local computer. So it just lives there, data path, and then there's a couple of parameters that you may want to specify. So for instance, you can specify train. That means that you're only going to download the train set because they're divided. There's a train set and a test set. So I think train set is 60,000 samples, if I remember correctly. And there's also a flag that you can define, such as download equal, and you can say something like true, in case you may not want to download, or you do, whatever. All right, so now let's go ahead and run that. And okay, so it's downloading, as you can see. Oh, and it finished. So now we have it. So let's go ahead and print out some information about Cipher 10. Let's do print Cipher 10, right? Oops, not 20, or 10. And you can see it tells us the number of data points. So we have 50,000 samples, and it tells us where it's located, and it tells us that this is the train set. So obviously, as we start building some neural networks, we can use this to train our data. Does that make sense? This is a quick way of like building models that are pretty good and kind of fast. Any questions?
Can't download.
It won't download?
No. Yeah. So,
That's the sound. How about other people that tried
I
it?
would say,
It downloaded on the local computers? Loaded, maybe you didn't load it. How about, did it fail for everyone? The download of Cypher 10? So it could be what, on your local computers, could be an issue with the school computers. For some of you that have laptops, you got it to work, correct? And I'm using a laptop. So it may just be, huh? Did you get it to work? Well, all we did is Torch Vision, which I installed via pip install, right? This, and I had installed, I was running before Torch. That's it. Torch, NumPy. That's pretty much it. So it's possible that it's something related to the school computers. That, you know, because it's a connection to the internet. So,
they probably don't want you to download something so naturally.
cool, the university?
Yeah.
I mean, it could be something like that, that they don't want, yeah, I mean, yeah, so, but anyway, so that we're almost done with this. So basically you would download the file as I did. And then after that, it's something we'll have to figure out because we will need this for some assignments later on, but we don't need it for now. So just to kind of conclude, so I downloaded Cypher 10, and then I can actually access something of Cypher 10, like an image and a label, right? So this is a classification data set. So for instance, I can do from Cypher 10, I can select one item. So for instance, 45, right? There's 50,000 items in there, and I can retrieve the corresponding image and the label. Okay, so if I do this, I have it basically, and now I can print out the label, which is a number, which corresponds to some category. Okay, so we would have to look at the documentation for Cypher 10 to see which label it is, but we can look at the image, hopefully, and know. So the image should be of a, what is that? A car, I believe. So they're very small images. Now, to us, it's very difficult to see these images, but for machine learning, actually, this might be simple enough. Okay, guys? That's basically it, actually, as far as using data sets. So again, apparently there's an issue. Nobody that's using a local computer was able to download this. You found a workaround? What is it?
it's just like, import SSL and then it's like a really long, SSL, _create default. the context that was created on the content.
And then after that, you were able to download it?
Downloaded that, followed along. I can just return it.
Okay, all right, perfect, yeah, great, yeah, so that's good, okay? So I'm glad, all right, that's basically it as far as the basics and loading data, okay? So this is kind of what I wanted to show you. So I'll stop sharing and I'll stop the